In this part, we will talk about inequalities. First, let's look at some interval notations. So let's look at the interval. The first column would be the interval. The second column would be the corresponding inequality. And the third column would be the graph. Okay, so for example, if you have an interval which is 3 to 5, we use the bracket. That means the endpoints 3 and 5 are included, which is between 3 and 5, and 3, 5 are included. So that means x is greater than or equal to 3, less than or equal to 5. If for the lines, if this is 3 and this is 5, so we use the bracket. On 3 and 5, that means these 2 points are included, and the region should be between these 2 points, and these 2 endpoints are included. If you have -2, 1, so that we use parentheses, that means the endpoints are not included. So it becomes x greater than -2 and less than 1. So if you use the line, so this is -2, this is 1, so we use the parentheses. That means this point are not included, but x should be between these 2 points. And we have -3 to positive infinity. So that means x is greater than -3. Okay, infinity, keep in mind, infinity is not a number. So you always have a parenthesis for the infinity because you cannot include infinity. So that is x greater than -3. So you have -3 here. So greater than -3, so that would be this one. If you have -infinity to 2, that is x is less than 2. From the graph, you have 2 here, less than 2. And you have -infinity to 2 included. So that is x is less than or equal to 2. This is the graph. You have -3 to positive infinity. So this is x greater than or equal to -3. The last case is -infinity to infinity. That is all real numbers. X is all real numbers. In other words, x is between -infinity and positive infinity. So that is the whole number line. Okay, so now let's look at some inequalities. So when you solve some inequalities, it's like the solved equation, but there is a little bit difference. When you divide, keep in mind, when you multiply or divide an inequality by a negative number, we should reverse the direction of the inequalities. So now let's look at this example. 6 plus 5 times 1 minus x less than or equal to 7. So when you solve this equation, this inequality, the first several steps are almost the same as the equation. We needed to isolate, expand, isolate x terms on one side. So this is the 6 plus 5 minus 5x less than equal to 7. Okay, so this is 11 minus 5x less than equal to 7. We need to isolate x term on one side, so we subtract 11 on both sides. So you have negative 5x less than equal to negative 4, right? Now, we need to divide by negative 5. Then we have only x term on the one x on one side, right? But that is the difference between the equations and the inequality. When you divide or multiply a negative number for the inequalities, you need to reverse the direction of the inequality. So we divide by negative 5, so x equals, so this is the negative 4 over negative 5, right? So we needed to reverse less than equal to becomes greater than equal to. So you have x is greater than equal to 4 over 5. If you use the interval notation, it would be 4 over 5 to positive infinity. I'll just write down the infinity. So now let's look at another inequality, which is called the sandwich inequality. Okay, the sandwich inequality. So the idea is we always want to keep the variable in the middle. Okay. So the first thing is we need to multiply by 5 to get rid of the denominator, right? So each term multiplied by 5. Okay, so this is the negative 1 times 5. Since we multiply a positive number, we will not change the inequality, the direction of the inequality. So we just keep less than. This is 2x minus 4 over 5 times 5 less than 0 times 5. We multiply each term by 5. Okay, so this is negative 5 less than 2x minus 4 less than 0, right? So we add 4. And we want to keep the variable in the middle. So we add 4 on both sides. So this is negative 1 less than 2x less than 4. Then we divide by 2. Divide by 2. When you divide a positive number, you will not change the direction of the inequalities, right? So we divide by 2, so you have negative 1/2 less than x divided by 2, so this is 2. So that is your answer. So interval notation would be negative 2, negative 1/2 to 2 using the parentheses. The next inequality, which is absolute value inequalities. Absolute value inequality. That is the inequality many students have trouble with. Well, so when you solve, the absolute value inequality have two types. Okay, the first type is some equation about x. The absolute value of u is less than 0, less than c. C is a positive number. The second one is the absolute value of u is greater than c. So here could be less than equal to or greater than equal. It doesn't matter. So if you have x less than absolute value of u less than c, the same idea as the equation involving the absolute values. So we need to get rid of these two parts, right? So we need to use this definition. The absolute value of u less than c. What does this mean? This means u is between negative c and c. Okay, so the same thing for absolute value of u less than equal to c. It means u is between negative c and less than equal to greater than equal to negative c and less than equal to c. For this one would be u is greater than c or u is less than negative c. Okay, so for this inequalities, it actually can be decomposed into two new inequalities. The same thing is the absolute value of u greater than equal to c, so it means u greater than equal to c or u is less than equal to negative c. So keep in mind this. You should know this equivalence. Then you can solve the inequality involving the absolute value. So now let's look at this example. The x minus 3 is less than equal to 1. So which is actually the first case, right? The first case, the second part of the first case. So that means x minus 3 should be between negative 1 and 1. So the same thing, this is the sandwich inequality, so add 3 on both sides. So it becomes 2 less than equal to x and 4. So your solution would be from 2 to 4. This is the interval notation. Let's look at another example. This is the 2x plus 1 greater than 5. So that is the second case, right? Second case. So it means it can be written as two new inequalities without the absolute value sign. So that means 2x plus 1 should be greater than 5. This is the 1, but don't forget the other one, or 2x plus 1 should be less than negative 5. Let's solve the first inequality. This is the minus 1, so it becomes greater than 4 divided by 2, since 2 is positive, so you still keep the inequalities. And for this inequality, you will have 2x less than negative 6. And x is less than, we divide by 2, 2 is positive number, so it will not change the direction of the inequality, so it would be negative 3. So put together, we will have the solution is x greater than 2 or x less than negative 3. These two cases cannot hold simultaneously, because x greater than 2, then x cannot be less than negative 3, right? At the same time. So we use or. Okay, if you use the interval notation, it would be 2 to positive infinity, and this one is negative infinity to negative 3, right? So which symbol to represent or? We use the union. Okay, this interval union that interval, that means we can just take either one, but not at the same time.